Hello, drone pilots. For this week, lesson 2, the objectives are the FAA laws. We're going to talk about that a little bit. We're going to talk about mission 1, and I'm going to explain what the engineering design process is. The Federal Aviation Agency, or FAA, their job is to ensure safety of our national airspace. So they are concerned about mid-air collisions, planes flying into houses, and of course, terrorist attacks. So the FAA does not like drones. There are some obvious reasons. The drone can hit the airplane, get sucked into the engine, cause pilots to veer out of the way. So there's a very real threat with drones and air traffic. So rather than saying no drones allowed, the FAA does allow, but does have some restrictions. And you might wonder, well, why? Let's just not have drones. It's too dangerous. And if you go to the FAA website, you can see they have something they call the drone zone, where you can get all kinds of information about flying your drone, how to get your license, how to register your drone. So why are they playing nice? So to put it simply, it's about the money. Billions of dollars will be saved using drones for agriculture, for inspections, for security surveillance. Lots of money is going to be made in the drone industry, in the technology, for entertainment, in the military, and thousands of jobs are going to be created. So the drone industry is here to stay. Rather than get in the way of the drone industry, FAA has come to compromise on how can we still be safe and have the drone industry thrive. So here are the FAA regulations. Do not fly over people. Do not fly your drone when it is dark. Do not fly your drone within 5 miles of an airport. Do not fly your drone above 400 feet. Do not fly your drone over private property. And the last, do not fly beyond line of sight. What that means is you cannot lose sight of your drone. You have to see where it is at all times when you're flying it. Thinking about mission 1, here we have 2 hikers. They've been bitten by rattlesnakes. They are somewhere in a mountain canyon, so they're surrounded by mountains. And we have to fly anti-venom by drone to these hikers within a time frame because they're already showing symptoms. Now, here we have our FAA laws, okay? We cannot fly over people, okay? I think we can get around that. Can't fly at night. Easy enough. We'll do the mission during the day. Can't fly 5 miles near an airport, so we have to check our maps, make sure that's safe. So here's a bit of an obstacle. Cannot fly over 400 feet, and I'm pretty sure these mountains are taller than 400 feet. So there we have an obstacle. Cannot fly over private property. I think we'll be okay if the national park is not considered private property. Cannot, and the last one, cannot fly beyond line of sight. Okay, so that too is going to present a tricky issue for us because these hikers are off in the mountains, in a canyon, and the whole point is we have to get this to them as quickly as possible. We are not near them. So what are we going to do? Our mission is presenting some obstacles and some challenges, and this is where I want to introduce to you the engineering design process. It is a series of steps that you take when you're trying to figure out a problem, okay? What's great about this process is it helps you take a big project or challenge and break it down into chunks. And research has shown that students who learn this process can apply it to any kind of situation that requires you to figure something out. So it's really practical and it's going to be helpful, especially as we do our missions. Here are the steps. So first step is called ask. And what's involved in that step is you're asking questions. What's going on? What do we need to know? What are some of the problems here? And this is where some research comes in. You're digging, trying to get as much information as you have. The next part is called brainstorm. And when you brainstorm, you're working together to figure out some solutions. Like, hey, what if we try this? Or what if we do that? The next step from brainstorm is you take those ideas and now plan it out. Who are the key players? Who's going to do what? When does the next person go? And you really try to map out what your idea is step by step. Then once you have your plan, you go to test. And this is where you're going to test it out and see if it actually works. And from there, you go to improve. So let's say it doesn't work. There's a glitch, there's a misstep, calculation is off. That's the improve phase, okay? And this is where you think about, okay, that didn't go too well. We crashed into this, or the battery died. Where do we make some improvements? And what you do to figure out what the improvements are, go back through the process and start with ask. So let's research. What more do we need to know about the battery? Let's say that was the problem. Let's brainstorm ideas around the battery. Let's plan, let's test, see if it works now. And if not, you start again, go to improve. Okay, how do we improve this? Well, let's ask. Okay, so you see the cycle here. The engineering design process is a name that applies to the process. What I've done is I've renamed the steps just a little bit so that it's more applicable to drone, and I'm using the acronym DRONE to help us remember it. So the first step is dig. Dig for answers, okay? And it has the same meaning as ask. The next step is we're going to rack our brain trying to figure out how to get to solutions. We're brainstorming. The next step is called optimize. Let's optimize, let's plan out, let's see how can we get this done the fastest and the safest. The next step is neutralize. It's our testing phase. And when you neutralize, what it means is we're going to get rid of any potential problems. So through testing it, we can see if this is working well or not. Okay, and that way we're working into how all of the steps will take place. And then finally for us, enhance is when after we've done the mission, we will check and see, did we follow safety protocols, speed, how were our calculations, and that way we can check ourselves to see, did we do the mission as best as possible. So here is a nice little graphic of our drone engineering design process. Dig, ask those questions. Rack brain, let's figure this out. Come up with some solutions. Optimize is where we're planning out our steps. Neutralize, let's test those steps and make sure those plans do not have any errors. And then finally, enhance is where we check for safety and for speed and professionalism. The engineering design process is for a team working together to come to a solution. Let's think about how we're going to do that. We need to collaborate. And that could be tricky in a cyber school, right? We don't have a class where we get to meet up and talk face to face and draw pictures. We do have live class, and maybe that's the best place where collaboration happens. So I'm looking forward to hearing from you guys. How do we collaborate? What's the best way to do it? Are we use Blackboard Collaborate in our live class? There's Skype. We could FaceTime. the discussion forums. So just give it a thought. What's the best way to go about it? Because the missions are going to be more complicated than you realize, and we should work together to solve it. That wraps up lesson 2. And let's figure out what works for us for our engineering design process and how we're going to collaborate. And look forward to seeing you guys in live class. Bye.